I wanted to make a video about a kinematics problem that involves a police car having to catch up to another car. So in this problem, we're asked to find the time it takes for the police car to catch the car, the final velocity of the police car, and the displacement of the cars. So for this problem, what's important to note is that we're going to set the point at which the police car starts moving as x equals 0. And when we want to find the time where they catch up, well, that will be when their displacement is equal. So wherever these two cars catch up, their displacement away from x equals 0 will be the same. And luckily we have an equation for position. We have our change in x equals our initial velocity times time plus 1/2 times our acceleration times t squared. So to assign some values to these cars, I'm going to say the police car is accelerating at a rate of 4 meters per second squared, and that my car is moving at 16 meters per second. So we know that both of these cars' displacements have to be equal. So we can say that the displacement of u has to equal the displacement of the police car. So now let's substitute in our values. So if I have v naught t plus 1/2 at squared, for me, well, I'm not accelerating, so that'll go to 0. And I'm just left with 16t. And then I have to set this equal to the police car. So if I have v naught t plus 1/2 at squared, well, the police car is starting from rest, so our v naught will be equal to 0. And I just have 1/2 times 4 times t squared. So now I can cross out a t from both sides, and this will just become 2. So I get t is equal to 16 divided by 2, which is equal to 8. So I get t equals 8. Okay, so now that I know that t equals 8, I'm able to solve for the final velocity of my police car. So the equation that I'm going to use to solve for the final velocity of the police car is going to be that final velocity equals v naught plus acceleration times time. And this is coming from what we use to calculate average acceleration. So if acceleration is equal to final velocity minus initial velocity over time, well, I can rearrange that to get to this equation. And this works because I do have a constant acceleration. This would not work if I didn't have a constant acceleration, but because we do, we're able to use this. So I'm going to say that VF equals, well, V naught is 0, so that it's just equal to 4 times 8, because that's my acceleration times time, which equals 32 meters per second. Okay, so now for the final step, we're going to solve for the displacement of the cars. And because we determined that the cars will be the same distance away from x equals 0 when they've caught up to each other, it doesn't matter which values we use for which car to calculate the final position. So I'm just going to say that delta x equals v naught t plus 1/2 at squared, which we know, and I'm going to use my car, the purple car, so I'm going to say, but it doesn't matter. So in this case, we wouldn't have an acceleration, so that would go to 0, and I'll just be left with 16 times 8, which equals 128 meters. So that would be my displacement of the cars. I hope this was helpful.